SpaceX just tested the most powerful rocket engine ever built, and when all 33 of them fire together, they produce more thrust than every rocket humanity has ever launched combined, and that number is not an exaggeration. Starship is not an upgrade. It is not an iteration. It is a complete reimagining of what a rocket can be, and SpaceX has now demonstrated through multiple integrated flight tests that the most ambitious launch vehicle in the history of human spaceflight is not a concept drawing or a computer simulation. It is a functioning machine that is getting closer to full operational capability with every single flight. To understand what makes Starship genuinely unprecedented, start with the numbers. The fully integrated vehicle, Super Heavy Booster plus Starship Upper Stage, stands 123 meters tall. For scale, the Saturn V rocket that carried Apollo astronauts to the moon stood 111 meters. Starship is taller, but height alone does not capture the difference. The Saturn V generated approximately 3,400 metric tons of thrust at liftoff. Super Heavy's 33 Raptor engines generate over 7,590 metric tons of thrust at liftoff, more than double the most powerful rocket ever previously flown. And unlike Saturn V, which was expendable and destroyed after every mission, Starship is designed to be fully and rapidly reusable, both stages returning to Earth and flying again. The Raptor engine powering this system is itself a remarkable engineering achievement that deserves its own recognition. Raptor burns liquid methane and liquid oxygen, a propellant combination chosen specifically because methane can theoretically be manufactured on Mars using local resources through the Sabatier reaction, combining carbon dioxide from the Martian atmosphere with hydrogen. This means Starship's fuel choice is not arbitrary. It is part of a long-term architecture for making Mars missions refuelable on the surface of another planet. The Raptor engine operates at a chamber pressure of approximately 300 bar, making it the highest chamber pressure rocket engine ever developed for operational use. Higher chamber pressure means more efficient combustion, which translates directly into better performance per unit of propellant consumed. The Raptor 3 variant currently in development is targeting performance improvements that would make it one of the most efficient large rocket engines ever built by specific impulse at sea level. Flight Test 5, conducted in October 2024, delivered the milestone that the global aerospace industry had been watching most closely. The Super Heavy booster returned to the Starbase launch site after separation and was caught mid-air by the launch tower's mechanical arm system, designated the Mechazilla chopstick arms by SpaceX. This had never been attempted anywhere in the world by any rocket program at any point in spaceflight history. The booster, weighing hundreds of metric tons, descended from the sky and was physically grabbed by two massive steel arms before it could touch the ground. The precision required to execute that catch, aligning a returning booster moving at controlled but still significant velocity with a fixed catching structure, is an engineering feat that the broader aerospace community described with undisguised astonishment. Flight Test 6 in November 2024 repeated the booster catch successfully and pushed the ship stage deeper into re-entry than any previous test, gathering critical thermal protection data from the highest stress portion of the return trajectory. The hexagonal tile-based thermal protection system covering the ship's windward surface is one of the most technically demanding elements of the entire vehicle, protecting the stainless steel structure from re-entry heating that reaches temperatures capable of melting conventional aluminum-based spacecraft structures. The payload capacity that full Starship reusability unlocks is transformative at a civilizational scale. In fully reusable configuration, Starship is designed to carry up to 100 metric tons to low Earth orbit. In expendable configuration, that number rises to approximately 150 metric tons. For comparison, the Saturn V carried approximately 130 metric tons to low Earth orbit, but was destroyed after every flight. Starship is designed to carry comparable or greater payloads and then land, be refueled, and fly again within hours in the long-term operational vision SpaceX is building toward. NASA has contracted Starship as the human landing system for the Artemis program, the vehicle that will carry astronauts from lunar orbit to the surface of the moon for the first time since 1972. The contract value across initial award and follow-on development funding has reached approximately $4 billion. The first crewed lunar landing attempt using Starship is currently targeted for 2026, contingent on completing the remaining flight test milestones, including demonstrating orbital propellant transfer between two Starship vehicles, which is a requirement for the lunar mission architecture. Beyond NASA, SpaceX has announced plans to use Starship for a series of missions that collectively represent the most ambitious launch manifest ever assembled by a private company. Point-to-point Earth transportation, carrying passengers between continents in under an hour, has been discussed as a long-term commercial application. Mars cargo missions preceding crewed landings. Satellite deployment at a scale that makes current Falcon 9 Starlink launches look modest by comparison. Starship's payload bay is large enough to carry an entire Hubble Space Telescope, fairing included, as a secondary consideration. The infrastructure being built at Starbase in Boca Chica, Texas, to support Starship operations is itself extraordinary. A second launch mount is under construction. Multiple ship and booster vehicles are in production simultaneously. The production rate SpaceX is targeting for Starship vehicles is intended to eventually support a launch cadence measured not in flights per year, but in flights per day. A vision that seems impossible until you remember that SpaceX said the same things about Falcon 9 reusability in 2013 and delivered on every claim. What SpaceX has unleashed with Starship is not just a rocket. It is the infrastructure layer that makes the multiplanetary future either possible or impossible. And right now, it is being proven flight by flight, catch by catch, and milestone by milestone. The most powerful rocket ever built is getting closer to operational status with every test. And what comes after operational status is the part of the story that changes everything. So tell me in the comments, when Starship becomes fully operational and launch costs to orbit drop by a factor of 10 or more, what do you think the first genuinely transformative application will be? Mass satellite deployment, moon base construction, Mars colonization, or something that nobody has publicly proposed yet? Follow this page right now, because every Starship milestone from here forward is a chapter in the most important engineering story of the 21st century, and we cover every single one.